Hello and welcome back to High Peak Education. I would like to perform a problem that pertains to a problem I posed in a previous lecture video about centripetal acceleration for a calculus-based Physics 1 class. So let's take a look. What centripetal acceleration is necessary to make a car follow a curve of radius 500 meters at 25.0 meters per second? That's about 56 miles per hour. B, how does that acceleration compare to g? In other words, find the acceleration in g's. Well, the idea is that we should first start with the equation for centripetal force. So I'll write that here to start. That should be v squared divided by r. Okay? And let me make that square look a little better. V squared, there we go, divided by r. And that is the equation for the centripetal acceleration. Now notice, I think the v is known, that's here, and I think the radius is also known, that's here. So, given its velocity squared divided by r, and we just want the magnitude, we can go ahead and plug in. So we'll say 25.0 meters per second, and we square that quantity, and we divide that by the radius of 500 meters. Okay? So let's show how to calculate this value. So let's go over here. So we'll say 25.0 squared, and we'll divide that by 500 meters. Now that should work just fine because the squared by order of operations happens before the division. So let's write this down. This is exactly equal to 1.25 meters per second squared. Okay, so this is, let's see, 1.25 meters per second squared. Now remember, this is a vector, so any vector should have direction. I mean, the problem doesn't specify only to do the magnitude, but if we do want the direction, okay, we probably should say, okay, it's centripetal, so we can say, at least in words, directed in towards the center of the circle. So that is directed inward toward the center of the circle. Okay. So that'll be the direction always. Okay, hope that makes sense. And then part B says, how does this acceleration compare to g? In other words, we want to find g's. Now, g's is a very common acceleration basket or bin or comparison. Turns out that g's is often used when we compare things for the human body, because we all know, most of us at least, what it feels like to say jump off of a high dive or jump off of a tall cliff into, let's say, water below or something. That feeling that you feel in your stomach, that's 1g. That's 1g magnitude of acceleration because we're in free fall. So we want to know how many free fall accelerations of g does this compare to? Well, let's investigate. So we should say g's, which in some sense is unitless, should be the acceleration, which in this case is the centripetal acceleration, divided by g itself for Earth. So this is 1.25 meters per second squared divided by 9.8 meters per second squared. Okay, and let's perform that calculation as well. So we need 1.25 divided by 9.8, and we should get exactly, well, not exactly, but we can round it to about 1.28 or so, the 3 significant digits. So let's see, approximately 1.28, or I said that wrong. 0.128, sorry for that, g's. So this is the amount of g's. Now this is pretty small, but that's because the car is on a very large radius curve, and we also note that the car is moving at a modest velocity, still a fast velocity, 56 miles per hour or 25.0 meters per second. But then furthermore, We can also say this is not nearly a substantial acceleration for a person's body. It turns out that a person's body, depending upon which plane you're in, so this plane or the side-to-side plane, the body can sustain usually around 5 Gs vertically before blacking out and around 3 Gs side to side. But this is the kind of the limit of my knowledge in terms of the human body. So Gs is just sort of a nice counting unit that we like to compare things against when looking at accelerations for the human body. So that ends this problem. Thank you very much for your attention. If you like this content, please smash that like button and please subscribe to the channel to grow the channel. Please share it with those in your sphere of influence, and I want to thank you very much for watching another High Peak Education video. And I will see you in the next video.